Assalamu alaikum. Today we will continue talking about equations and inequalities, part 2. At the end of this video, students will be able to solve a first degree inequality in one unknown, represent a first degree inequality in one unknown on a number line and write its solution as an interval, find the sign of first degree binomial of the form ax plus b, where a is different from 0. Before we start, please prepare the following materials: your textbook, pens, draft papers, copybook, and your calculator. Let's have a look back on intervals and their representation on a number line. This is a closed interval is represented by two closed boundaries with a line joining them. This is an open interval is represented by two open boundaries with a line joining them too. Semi-open or semi-closed from the right or from the left, represented by two boundaries, one open and one closed, with a line joining them. Intervals containing infinity are represented by boundary of the number and a line to the infinity. If it's a plus infinity, so the line goes to the right. If it's a minus infinity, the line goes to the left. The set R is represented by minus infinity plus infinity interval, represented on the number line by the whole line. Definition: let a and b be two real numbers and x an unknown where a is different from 0. We call an inequality of first degree in one unknown every inequality of the form ax plus b less than or equal to 0, ax plus b less than 0, ax plus b greater than or equal to 0, or x plus b greater than 0. Example: 2x minus 3 greater than or equal to 0, x plus 1 less than 0 are inequalities of the first degree in one unknown. We call every real number x0 such that ax0 plus b less than or equal to 0 a solution of the inequality ax plus b less than or equal to 0. This is verified for less than 0, greater than or equal to 0, and greater than 0. The set of solution S of the inequality x plus b less than or equal to 0 is defined by S equal x0 belongs to R such that ax0 plus b less than or equal to 0. Also, this is verified for less than 0, greater than or equal to 0, and greater than 0. In this set, this means that every real number that verifies the inequality is an element of the set of solutions. Example: recognize whether the real numbers 1 and 4 are solutions of the inequality x plus 5 less than 7. First, we substitute x by 1 to have 1 plus 5, which is equal to 6. 6 is less than 7, so 1 is a solution. But if we substitute 4, we will get 4 plus 5 that's equal to 9. 9 is not less than 7, so 4 is not a solution. Solutions of inequality. Given the inequality ax plus b less than or equal to 0, we have two cases. The first case, if a is greater than 0, we will get x less than or equal to minus b over a, and the solution set is s equal minus infinity till minus b over a. Here we close the interval since we have less than or equal. If a is less than 0, so the solution becomes x greater than or equal minus b over a. We flip the order since we divided by a negative number, a is less than 0, and the solution set is s equal minus b over a till plus infinity. Example: solve the following inequalities. 3x minus 9 less than 0 or equal to 0, half x minus 3 less than x plus 2. Solution: 1. 3x less than or equal to 9, so we get x less than or equal to 9 over 3, thus x is less than or equal to 3. The solution set is s equal minus infinity till 3. 3 is closed since we have less than or equal. 2. We have half x minus x less than 3 plus 2, so minus half x is less than 5, and thus x is greater than minus 5 over half. We flip the order since we divided by minus half a negative number, and then x is greater than minus 10, and so the solution set is s equal minus 10 till plus infinity, minus 10 with open boundary since we didn't have greater than or equal. This is strictly greater than minus 10. Application: solve each of the following inequalities and derive the solution in interval form, then represent it on a number line. Solution: 1. 2x plus 6 greater than or equal to 0. This gives that 2x greater than or equal minus 6, and so x is greater than or equal minus 3. The solution in the interval form is the set s equal minus 3 plus infinity. Minus 3 is closed since we have greater than or equal, and tends to plus infinity because of greater than. The solution on the number line, we have the minus 3 boundary with a closed interval, and this goes to plus infinity, so the line goes to the right. 2. 6x minus 3 greater than 11x plus 17, so 6x minus 11x is greater than 3 plus 17, so minus 5x greater than 20. Then x is less than minus 20 over 5. We divide by minus 5, a negative number, we flip the order, so x is less than minus 4. The solution in the interval form is the set s equal minus infinity till minus 4, open on minus 4 since it's strictly less than minus 4. The solution on the number line is represented as the following. We have minus 4, open interval, and the line goes to minus infinity, so it goes to the left. Given the binomial 2x minus 4, where a is equal to 2 greater than 0. A is the coefficient of the variable, the unknown x. The sign of 2x minus 4 is determined by 3 steps. 1. We find the root of the binomial 2x minus 4. We get 2x minus 4 equals 0, so 2x equal to 4, then x is equal to 2. We study the case where 2x minus 4 greater than 0 to get 2x greater than 4, and so x is greater than 4 over 2, thus x is greater than 2. And 2x minus 4 is less than 0, that gives 2x is less than 4, and so x is less than 4 over 2, thus x is less than 2. The following table summarizes the study of the sign of the binomial 2x minus 4. The table shows that first we write x, the whole domain from minus infinity to plus infinity, and here we put the root of 2x minus 4, which is 2. Then 2x minus 4, from here we get x is greater than 2, 2x minus 4 greater than 0, x greater than 2, so we have in this section 2x minus 4 greater than 0, so positive sign. If x is less than 2, we have 2x minus 4 less than 0, so in this section x is less than 2, and 2x minus 4 is less than 0, so we have a negative sign. A is equal to 2, so A is positive, and A is positive in all the sections. We have, before the root, a negative sign which is opposite to the sign of A, and after the root we have a positive sign which is the same sign of A. Given the binomial minus 3x plus 6, A is equal to minus 3, which is a negative number. As we said before, we have 3 steps. First, minus 3x plus 6 equal to 0, so 3x equal to 6, and then x is equal to 2 is the root of this binomial. Minus 3x plus 6 greater than 0, so minus 3x greater than minus 6, and then x is less than 6 over 3, and so x is less than 2. The third step, minus 3x plus 6 less than 0, so minus 3x less than minus 6, and so x greater than 6 over 3, we divided by a negative number minus 3, so flip the order, and so x is greater than 2. Also, this study is summarized by the given table. We have x minus infinity plus infinity, the whole domain. We put the root here. The root is x equal to 2. At 2, the binomial is equal to 0. We have from here minus 3x plus 6 greater than 0 if x is less than 2. So in this section, x less than 2, we have a positive sign. And from here, minus 3x plus 6 less than 0, a negative sign if x is greater than 2. So in this section, x is greater than 2, and we have a negative sign. The sign of A that's equal to minus 3 is negative in the whole domain, and we recognize that before the root we have a positive sign which is opposite to the sign of A, and after the root we have a negative sign which is the same sign of A. Property. Given the binomial ax plus b, to study the sign of ax plus b we have two steps. First step, find the roots of ax plus b, so solve ax plus b equal to 0. Second step, set up the table of signs of ax plus b. The table is summarized as the following. The table of signs, here the variable x, the unknown x, the domain from minus infinity to plus infinity. We put the root minus b over a. At the root the polynomial is, or the binomial is equal to 0. Before the root we have the opposite sign of a, and after the root we have the same sign as a. Example. Study the sign of each of the following binomials. 4x minus 2, 35 minus 7x. 1. Solution. First, we need to find the root of the binomial for x minus 2 equal to 0, then x equal to over 4, and thus x equal to half. Then we draw the table of signs. X minus infinity plus infinity, we put the root half. At the root the binomial is equal to 0. Before the root we have opposite sign of a, and after the root we have the same sign of a. Here a is equal to 4, where it's positive, so before the root opposite sign of a, so we get a negative sign, and after the root we have the same sign of a, and so we get a positive sign. 2. 35 minus 7x equal to 0, then x equal to 5. Here a is equal to minus 7, the coefficient of x, which is a negative number. We draw the table. X minus infinity plus infinity, the whole domain as we said before. Here 5, the root of the binomial. At 5 the binomial is equal to 0. Before the root we have opposite sign of a, and after the root the same sign of a. The sign of a is negative, so opposite sign of a is positive. The same sign of a is negative. This table says that 35 minus 7x is positive between minus infinity and 5, and it's negative between 5 and plus infinity, and it's equal to 0 at x equal 5. Application. Study the sign of each of the following binomials. Solution. 1. 2x minus 3. We find the root, so we solve to x minus 3 equal to 0, then x equal 3 over 2. Here a is equal to 2, the coefficient of x, so it's a positive number. Then we draw the table. We have x minus infinity plus infinity. The root is 3 over 2. At 3 over 2 to x minus 3 equal to 0. Before the root we have opposite sign of a is positive, opposite sign of a is negative. After the root we have the same sign of a is positive, so here we have a positive sign. 2. Minus 3x plus 4 equal to 0, x equal 4 over 3, and a equal minus 3, the coefficient of x, which is a negative number. The table, x minus infinity plus infinity, we put the root 4 over 3. At 4 over 3 the binomial is equal to 0. Before the root the sign is opposite sign of a is negative, so opposite sign of a is positive, and after the root we have same sign of a is negative, so here we have a negative sign. Do the assignment. Focus on the summary coming next. See you in the next video. Please stay safe.